Hey Defender, so last week we released some of our DFIR-IRIS modules that we like to use and that integrate with some of our other open source tools that we have currently deployed to help make up our Seam stack. And in this video, I want to quickly show you guys how we actually install these modules and how we can configure and run them and go into a little more details about each of these modules. So each of the modules here, the 5 that we have here, have their own Git repo as well. So if I open up, let's just say the SOCFortress repository, and if I scroll down to the install section, we will have the few commands that we'll need to run to actually install the modules. And so what's going to happen is that we actually need to, since Iris is Dockerized, we need to install the modules within the various containers. So if I do a Docker PS, we will see that Iris as a whole makes up a few containers, but where we need to actually deploy our modules to is in this Iris web app and this Iris web worker. Both of these containers need to install the actual module. So this will need to be done on the same server that is actually running Iris, of course. And I actually am just going to make my own directory, and I'll just call it Iris modules. I'll cd into there. And you, of course, do have to have Git installed because we are just going to clone all the repositories. So I'll run a Git clone to grab that guy. I'll cd into the SOCFortress module. And now you'll see we have this build and push to Iris bash script. So you could manually do the deployment where you copy the wheel file into the actual containers, then actually install them within the containers and then reload the containers. But this process just automates that for you. So it's a lot faster, trust me. So we'll go ahead and change the permissions to the bash script to make it an executable. And then I'm going to go ahead and call this, and I'm going to give it the -a flag as well. And what's that going to do is build our wheel file and then copy that into our worker container. So you see our worker container is now restarting, and then also the web container as well. Cool. And now once that is installed, now what we need to do is actually configure the module within Iris itself. So if I log into the web UI here, and if I scroll down into advanced and select modules, I'll have the ability to add a module. So what I'm going to now do is I have to call the module name, and the module name is going to be in the Git repos as well. So here I have my install section. If I scroll down to my configuration, you'll see on step 3, we need to input the module name. So I'm going to go ahead and copy this value and paste that there and select validate. I already have this module installed, so it's going to say, hey, it already exists. But you should see that yours has been successfully added. And when that does occur, you will now get a new module called the SOCFortress beta. And if you select this guy, you'll have the ability to set your configuration. So with this particular module, your only unique values are going to be your API key, which if you don't have one yet, you can request one there's a link to request one within the Git repo. And then also the firewall model. I'm not going to go into too much depth as to what exactly these modules are doing. You can read up on that on the Git repo. So I've got my API key set and my firewall model set here in my local lab. I'm just using a pfSense firewall. So that all looks good. So now to actually invoke and run this module is going to be able to be ran on any IOCs. I'll just select an IOC. If I select my submenu here, we have the ability to run the SOCFortress module. So I'll go ahead and kick that off, and that is going to run the module within the actual worker of Iris. So he's going to be doing the heavy lifting of whatever the Python script requires to be done. And then if I refresh the page, so as of now, you do have to manually refresh. It won't auto-populate with your tab here. But hopefully in later versions of Iris, we have a way to auto-refresh once the results come back. But you then get a tab with your SOCFortress report. So you get all your details here. Good. So let's go ahead and install one more module. I'll just do the Cortex analyzer one, and then I will skip ahead and just install the rest of them, and then skip ahead so the video is not longer than it needs to be. So I'm going to do the same steps when it comes to the Cortex analyzer. I'm going to go ahead and I'll go ahead and cd go back a directory back into my Iris modules, run our git clone, go into our Cortex Iris Cortex Analyzer module directory. And now I will again make this an executable and run the same command. So I'll call the bash script, give it the -a flag, and it's now going to build our wheel file and copy it into the respected containers and then restart the containers as well. And if you have some errors here, don't worry about that. You can disregard those. And then I'll go ahead and get the Iris Cortex Analyzer module name copied in my buffer here. And I'm going to take those same steps. So go ahead and select Advanced, select Modules, select my plus icon to add a module, and I'll go ahead and paste that module name in. And then you should see that your module has successfully been added. And now we have some other variables we need to set. So we first need to set the endpoint for Cortex's API. So you're going to point to your Cortex server on port 9001, which is the default for Cortex's API. We are then going to provide the Cortex API key. And if you need assistance with that, I have some previous Cortex videos that I'll link in the description below. And then you also need to set the Cortex Analyzer. And the Cortex Analyzer is going to be the actual analyzer name within Cortex itself. So if I log into Cortex here, you'll see that I have my analyzers available here. You see I have 185 of them. And in this particular instance, I want to run the virus total get report _3_0. So if you need help getting the analyzer name, you could just come to your analyzers within Cortex and just straight up copy the name and paste it within here. Another note, these modules do have to be enabled. So you'll see out of these 5 here, I only have the virus total get report one enabled. So if I tried to run this virus share one, it wouldn't work because the analyzer within Cortex is currently not enabled. Essentially what this module is doing is invoking Cortex's API, telling it to run this analyzer and to get us back the results. So go ahead and save that off. And if I dismiss that out, and if I go back, again, the Cortex Analyzer can also only be run on IOC. So I'll go to my IOC tab, select my submenu, select the Run Cortex Analyzer, and now my worker is now running this analysis within the background for me. And then once that is complete, I'm able to refresh, and then you will have your Cortex Report tab up here, and then you'll be able to expand the Cortex Analyzer results and see the JSON output of the actual analysis, which is really nice because now we're not having to bounce back and forth between Cortex and Iris to run our analysis. We can integrate it all into one. What I'm hoping to work with the Iris team with is that instead of like having to now, because now I would have to go back into my Cortex Analyzer module and change my analyzer name to, let's say I wanted to run like this analyzer, for example. You know, that just, it takes too much time and really isn't optimal for how we would like to run our analysis. So I'm hoping to work with the team to where when you select the IOC itself, like when you select your submenu to run your available analyzer, instead of just running off immediately, having like a submenu pop up that allows you to select any of the analyzers that you currently have available, and then it runs the job. So hopefully we'll be able to provide that update soon for you guys and make it a little more user-friendly. So there are 4 other modules, or 3, well, technically 4 because the quarantine and remove quarantine are separate modules. But we have these 3 modules here, and the install steps would be the same. So again, you'll just follow the link to their repositories, scroll down to the install guide that you see here, run these commands, and then actually input the module name. And we have our wazuh-indexer module. Now, when it comes to configuring that module, so essentially what this module is doing is searching our indexes for events that match whatever IOC that we're currently investigating. So say, for example, if we got an alert for a host connecting to a malicious IP address, and we're like, I want to go ahead and scan the rest of my logs that I've ingested into my Steam stack to see if any other hosts have connected to this IP address. And so what's going to happen is after running the analysis, our hits will be displayed back to us here. So we'll see that, oh, this agent, this host name has also connected out to evil.socfortress.co. So in this example, it's a DNS query. And we'll now get a collection of artifacts as to, okay, what other hosts or what other events occurred where my IP address is the same, or my domain name is the same, or my hash value or file name is the same. So it's helpful when doing kind of a massive search around your ingested SteamStack logs to hopefully you could of course run like, Grafana queries or Kibana queries to do the same thing for sure. But this is just a nice way to build it into Iris itself. And what you'll need to also configure are going to be your field names. So go back into the configuration of the module itself. We have a domain field that we need to set, an IP field that we need to set, a SHA-256, and a file name that we need to set. So looking at our domain field, for my instance, I have DNS query. If I jump onto my Grafana instance here, and I'll just load, we'll just say the DNS request since that's the field name that we're looking at. I'll scroll down and I'll just pick one of these guys here. And if I expand this drop down, you'll see all of my field names here. So these are the field names that we are referring to. If you're just using Kibana and not Grafana, it'd be the same thing. You'd open up Kibana's Discover tab, look at the field names, and select the appropriate field name that you want to search on. So in my particular instance, I'm using DNS_query. And if I scroll down, we see the field name DNS_query. I could have also used the data_win event data_query name as well. However, I am doing some like normalization to where regardless of the tool, I upload it to this DNS query name, but I kind of touched on that stuff in the Greylog deployment video. So I could use either one of these two names. If you have a different field name or the query names for your DNS requests are stored somewhere different, you would just change your field name accordingly. So if I wanted to change this to event data query name, I go ahead and just simply paste that value into there and then select save. I'll then do the same thing for the IP fields or the SHA-256 fields or the file name field. So this allows you to customize it to fit the field names that you may require. Then when it comes to running this module, same thing. We'll go back into the case thing. So let's actually, since we give an example of a DNS query, I'll go ahead and select this domain, select my submenu here, and select the search wazuh-indexer. So it's going to kick it off in the background. And now if I refresh my page, select my IOC again, select my wazuh-indexer report, we see that we got a total of 2 hits. And if I select this drop down, we'll see the host query out to evil.socfortress.co. Now for the quarantining of a device. So if I go ahead and open up this repo, again, if we go into the install guide, we will have the same git clone and the same bash script to actually run that. And then we are going to input the module name of Iris Velo Quarantine module. Prior to actually installing the module so we're using Velociraptor to do the quarantining and the unquarantining of endpoints. And to interact with Velociraptor's API, we actually generate this api.config.yaml file. And what we need in this file is what gives us the authentication to actually interact with Velociraptor's API. So because we are working in a Dockerized environment, we actually need to copy this YAML file into the workers themselves. So we need to modify within Iris's Docker Compose file a volume that mounts our API config.yaml file into the actual container itself. So within the container, if I were to bash into the container, I would be able to follow this file path to get my api.config.yaml within the web app and then also within the worker. So it's going to be the same within the worker as well. So if I open up my Docker Compose file for Iris, which should be in your Iris web directory. So if I ls this out, you'll see our Docker Compose.yaml. If we go ahead and open that up, if I scroll down to the app section here, you'll see that I have a volume for our api.config.yaml. So make sure that this is there prior to actually installing the Velociraptor module. And the same will also apply for the worker as well. So you'll just need to apply these. Of course, you will have to do a docker compose down and then run a docker compose up -d to actually bring Iris back up and running. And you will have to restart it so that docker compose reads the new addition to the compose file that we just added. And unfortunately, still after every Iris restart, you do have to rerun the build and push to Iris bash script for all of the modules. It won't erase your configuration for the modules, but you will have to reinstall them within the containers. So I'll go ahead and copy this module name, copy the Velo quarantine module, go back to my modules, again, paste that there, and validate it and actually configure it. And now if we select our Velociraptor quarantine module, you'll see the only configuration that we actually need to apply is where that API config file currently sits. And you'll see my value is to our /iris web app /api.config.yaml. Again, that's going to be the same path as where we did our volume mount within our Docker Compose file, which is here. So make sure you do have that applied correctly, or else the module will not be able to authenticate with Velociraptor. And now the Velociraptor quarantine and remove quarantine, so both are actually within their separate repo. So we have the quarantine one here, and then the remove quarantine will actually be another module that sits within our repository as well. So make sure you install that piece as well. And then the quarantine and removal quarantines are actually done on the asset. So rather than going into my case and going into IOC, I'm actually going to now go into asset. I see my Windows endpoint here that was associated with the alert. And if I select that asset, I'll have a similar menu. And here I can run my quarantine. So I'll go ahead and select quarantine endpoint. And then similarly, when I'm ready to remove the quarantine, I'll just select the remove quarantine, and that's going to kick off the Velociraptor API to then unquarantine the device. Now, the last module I want to touch on is actually the Velociraptor artifact module. So Velociraptor comes pre-configured with a ton of artifacts that you can run to really help your investigation comes to responding to alerts. With this module, it's going to be the same thing. We need to, again, make sure that our API config YAML file is within the worker. Similar steps to actually install the Velociraptor artifact module. And then you would input the module name that we see there. And then once inputted, you will have your Velociraptor artifact module. So we still have our API config file that we're having to point to authenticate with Velociraptor. And then we also have the same, similarly to the Cortex analyzer module, is the selection of the Velociraptor artifact that you actually want to run. So if I log into my Velociraptor instance, you'll see we have all of our artifacts available for us here. And these are going to be the artifacts names that we will input into the module within Iris that we want to run. So let's say, for example, I want to run this Windows Network netstat to show what open sockets my Windows endpoint may currently have at this time. So I'll go ahead and copy the artifact name. I'll go ahead and paste that here as my value, select save, and go into my case. The Velociraptor artifact, just like the quarantines, are also going to have to run on the asset and not an IOC. So I'll select my asset, select my submenu here, select the run the Velociraptor artifact. It is going to kick off in the background. And once it is finished, I will need to refresh my page, and you'll see our tab has been added here, titled with the artifact name that we actually had Velociraptor run. So here is our Windows Network netstat. And if I select our dropdown, you'll see we'll get the output that resulted from our Velociraptor run, which is pretty cool. So now I'm getting all of the open sockets on my Windows endpoint. Another cool thing that we do is also we're able to add it to the data store. So if we exit out of that and actually select our data store within Iris, you'll also see that file has been added here with the results. And here we're able to download it to a CSV and maybe I don't know, take it offline somewhere or send it to a client or a user to see if it's a false positive or not, or whatever you're looking to do with that, you'll have the ability to add that there. We can also, and again, similar like with the Cortex analyzer, if you want to run a different artifact, you would need to, let's just do like the Chrome history one, replace that value here, save that off. I'll go back into my asset, select this guy, select run Velociraptor artifact. Velociraptor is now going to run the Chrome history artifact. And once those results come back, I'll go ahead and refresh the page, select my asset again, and you'll now see that we have a new tab called the Chrome history. Let's go ahead and actually download this from the data store so I can show you guys kind of what that looks like. So we'll go ahead and select our data store. You'll see our Chrome history file has now been added. I'll select download, go ahead and open this up. I'll just open up in Notepad, even though it's not going to be the cleanest. And then you will see our JSON output that we have here. So pretty cool. I do know some of these aren't as convenient as they could be, especially the Velociraptor and the Cortex modules, just because you always have to change the artifact or the analyzer that you want to run within the config of the module itself. I know that's not very convenient, but I hope to work with the Iris guys where we can find a better solution to that, so that now you're not always having to change that. It'll just automatically pull up the artifacts and analyzers that you have available to run, and then you can run them straight from there. And I hope to be able to add on to these modules and introduce new modules as I myself figure out more use cases for Iris, or any ideas that you guys have, bring to our attention, and we'll see how we can help possibly module to integrate into Iris. And really nothing is off limits, which makes this really awesome because these are all just Python scripts. So if you're wanting to interact with a tool or service that has an API, then we can 100% integrate it into Iris, which makes Iris really flexible, and hopefully we'll just be able to keep building onto these analyzers as newer tools come out and better ideas come out from the community. So thank you guys for your time. Please feel free to install any or all of these modules that you may wish, and feel free to reach out to us if you have any questions or issues. And I appreciate you guys' time, and I will see you in the next one.